Hello everyone. So in today's video, we'll be looking at bash commands, and we'll also be exploring a lot of different commands that can help you navigate your operating system better, work with files, move directories, and do a bunch of different things to your command line interface. And towards the end of this video, we'll also be looking at how you can set up Node.js in your own systems. But before we get started, let's just understand what exactly is bash. So bash is nothing but a command line interpreter language that lets you interact with your operating system. So if we look at a standard terminal that is present in any Unix-based machine, what you see in front of you is a prompt. And you can give any instructions to your operating system to execute. So the job of the shell or your command line interface is to understand and interpret this prompt that you've given, and it is then executed by the kernel. So your shell is basically abstracting away all of the intricacies of your operating system for you. So let's get started. Now, the most basic thing that you would want to do when you're getting started with exploring directories or looking at what are the different things that are present in your computer is understanding what exists right now or where exactly are you. So in order to understand which directory are you currently located at, you can use a very simple command called pwd, which gives you the details of the present working directory. So I'm currently located in my documents directory. Now I want to understand what are the different directories that are present or files that are present within this directory. So we have a command called ls, which is used to list all of the files, directories, subdirectories, which are present under a given folder. So let's look at the output of ls. So I have a Zoom directory, I have a new directory. Let's understand what is there within the new directory. So I can just do ls on my new directory. Now, I cannot understand whether these are directories, these are files. So ls command comes with a lot of different options available to us with which we can look at details of the file, such as their last modified timestamp, their file size, their user permissions, and a bunch of more things. So let's look at some of those options really quickly. So the most basic way of looking at what each of the files and folders within your directory contain or details about that, you can use the option -L. And what you see here in the first column is the permissions of that particular folder. Since it is a directory, you will see that these permissions are preceded by a D. What you see here is the number of references that are there for these directories. This is the owner of this directory. This is the group owner. This is the size in bytes. This is the last modified date and timestamp, and this is the name of the directory. Now, let's say I want to look at few more details in terms of what exactly is present within my new directory. So what I can do very quickly is I can say ls-l new dir, and what I can see is all of the directories that are present within that directory. Now let's say I also want to look at what are the things which are present within each of these subdirectories. So in order to do that, we can just add another option called ls-r, and it will give us details of all of the subdirectories as well. So within Snake Game, we have multiple subdirectories, and within those subdirectories, we can look at each of the files. Okay, now that we know how to list files and folders within a given directory, what we are trying to understand is how can I get the list of directories and understand what was the last modified first. So for that, we have a very simple option called -t. And now the good thing about all of these commands is that you can combine multiple options together. So we can just say ls-lt, and we can also look at the timestamp of when it was last modified. So you see the one which was the oldest files are at the last and the newest ones are in the beginning. Now, what you can also do is that not all of the files are visible when you're working with private keys or environment keys of certain APIs. You would store those information in certain environment files. So if you look at it, I don't think you will be able to see anything. Let's say we just do it for the Snake Game. Now, in order to see all of the hidden files, we can do ls-la. So you see that all of the files which are preceded by a dot are essentially the hidden files. And we can also look at the hidden files which could be present within these subdirectories, and we can add a very simple option, which was -r, so that it recursively lists all of the directories for us. So there are a bunch of hidden files that are present, which is generally the Git files. We don't have a lot of hidden files here, but mostly the yarn and the Git files, which are important. Now, we've looked at different options, which gives us hidden files, which lists the details of the files. We've also seen how we can get the timestamp-based ordering. If, let's say, you want the reverse of what you have seen, using the timestamp-based ordering, you can use the command called r -r that basically gives you all of the files in the reverse order of what it was modified at. If you want to see it at the new directory level, this is exactly what you would be getting. Okay, let's say that we basically want to list the files in the reverse order. That's exactly what we did. We can also list these directories by all of the directories and files by size. So let's just probably look at one of them, which has a little bit more number of files within it. So this is basically the size of each of these folders and subfolders that are present. Now we have looked at ways in which we can look at what is present within each of these files. But before we go into intricacies of how you can visit each of these folders, look at a bunch of files, create new files, let me give you a few tips and tricks of how you can look at, find files and do a bunch of interesting things around with your directories. So now we want to look or find certain kinds of files within a given directory structure. And it's pretty simple. You can do it in a bunch of different ways. Let me show you one of the ways in which you can use the ls commands output along with grep to do that. You can also use wildcards to do that. So let's quickly look at the contents of the ZK Sudoku UI folder. There are a bunch of JSON files. There are JS files. We have CSS files as well. So I'm going to try and pull out all of the JSON files that we have. So what I'm going to do is I'm going to say that recursively give me all the outputs of this directory and just do a grep on all the JSON files. So it's going to give me all of the JSON files which are present. If I also want to look at all the JS scripts, it'll give me that as well. You can also do this at a higher directory level. You'll still get it because we are recursively looking at all of the directories and the subdirectories. Similarly, you can also search for these files at a specific folder level. So if you look at it, we were in the Sudoku JS folder. You can basically just do a wildcard of ls on this particular folder. Let me just quickly do that for you. So where are we currently? We are in this directory. We go to our new directory, snake game, and then we do cd to, okay, let's just omit the first directory because we are already within that directory. Now, all we are looking for is all of the JSON files present here. Since there are no JSON files, let's just look at what are the different files. So these are all the JS files. So we only want to look at all of the scripts. So you can just use wildcards at a directory level to get your desired files. All right, so what we looked at so far is how we interact with different directories, how we can list it out, different ways. There were long form, reverse order, timestamp-based ordering. And now there's a few tips and tricks that I'd like to share of how you can navigate these directories. Now, when it comes to looking at the subdirectories, I mean, you can just say ls-l, and it'll give you everything on new dir. And instead of doing a recursive search, similar to how we did it here, you can also look at the directories at quite, I would say, at the grassroots level as well. Now, let's say that you are searching for a particular file, which could be, let's say you're looking for Zoom-based directories. So you can just say you can basically use wildcards to specify the name of the kind of files that you're looking at. So this shows me all of the files that are present within that particular directory, which matches this regex. Another thing that you can also do is that you can also look at the directories which are present at the parent folder of this document. So if you look at my current directory structure, I am currently in the documents directory. If I want to look at all of the files and folders present at this particular directory level, I can just simply do dotted, and this will give me all of the directories and folders that are present. Now we have listed all the folders and files. Now I want to understand how I can go to each folder and do a bunch of things. So we have a command called cd, which basically means how you can change your directory to a directory of your choice. So let's say that maybe let's do an ls first. Look at what are the options we have. We say cd new dir. Now, if you look at the current directory, you are now present at the new directory. Again, you can do an ls over here. You can go to the directory of your choice. Let's go to Snake Game. You can do an ls here and look at all of the files. Now, when it comes to going forward, it's pretty easy. You can just specify the name of the directory and you can hop onto that directory. Now, what if you want to go back to the previous directory? So we can just use double dot to hop back to the previous directory, and you can do multiple hops. You just need to use the directory slash, and you can hop back to many levels. So if I do that, now my present working directory is going to be the user directory. I can very quickly jump back to my documents directory. I can go to this directory and Snake Game. Now, if you look at it, there are multiple files and folders that are present within this directory. Now, I am interested in viewing some of these files and also adding a bunch of new files to this directory. So viewing a file is pretty easy. We have a command called cat, with which you can view your files. It will give you a basic outline and just display it on your terminal. But that's not all. Cat command is pretty useful. It can also help you add data to any of a new file you have created, concatenate data to an existing file, and a bunch of different things. But before we go there, let's just first understand how you can create a new file. So let's say I want to create a file called new file. So I'll say touch is the command that we use. And I want to create a file called new file.txt. And if you do an ls now, you'll see that a new file.txt has been created. And now I want to add a bunch of things to this file. So what I can say is, okay, I want to add some data. I use the forward operator, specify the name of my file, and I can just keep entering text of my choice. I'm just entering random words, and then you can just press Control D. And now, if we go ahead and view the contents of this file, you will see that the file has been changed. Now, let's say I want to append a few details to this particular file. I can just use the double forward operator to add a bunch of more details to this particular file. If you look at it, it was simply appended at the end of the file. Now, this is something that I created in the same directory. Let's say I want to create a new directory within this directory. Think of it as if you're working on a full stack project and you have front end and back end and you want to separate it out. How do you create new directories? How do you create files within the new directories? So we have a command called mkdir that lets us create a new directory. Let's call it front end. Now, when you want to, if you look at it, our directory is actually created. We can just navigate it. And if you look at it, currently it's empty. Now, you would be thinking, can't we just combine all of these commands together? So you can actually do that. You can create a directory called test. And at the same time, using the double and operator, you can actually navigate to that directory within the same command. So if you look at it now, your current directory is the test directory. Now let's hop back to our original Snake Game directory. And look at a bunch of different things. Now, if you look here, there's a directory called zkDAP, and it has a bunch of different files and folders that are present within it. Okay, so we were looking at the zkDAP directory, and we want to create a bunch of different folders and create a proper project layout. So instead of creating your directories one by one, you can actually recursively create directories as well. So let's just quickly hop to the zk directory. Okay, probably we jumped the wrong directory. Let's go to zkDAP. All right. So what I want to do is I want to create a directory which says front end, and I want to create a directory which calls scripts and HTML. So what I'm going to quickly do is I'm going to say mkdir. I'm going to use the option called -p to recursively create directories, which is going to create a front end. I'm going to create a scripts directory. And then I'm also going to create a CSS directory, and I'm also going to create an IMG directory to hold all of my statics. So what we see after we have created everything when we do an ls-l on my front end is that all of these directories are actually created recursively. So don't just manually create directories, you can just use this feature. Now we have interacted with files, we've interacted with folders, we know how to create new files. We also know how to navigate our directories better. Now let's understand a few operations of how we can move files from one place to another. Let's say I have created a few generic data within these folders and I want it to be present in another folder as well. So let's clean our terminal a little bit, look at where we are at. Let's hop back to our previous directory. So let's say that I want this particular script.js to be called something else. So renaming a file in your generic GUI is very, very simple, but how do we do that in our bash commands? We use the command called mv. We want the script.js to now be called runtime script, pardon my spelling mistake, script.js. So now if you look at it, the file has been renamed. Now, let's say that you want to pick this file from this location and drop it at another location. You can also do that. So all we need to do is we say that move the runtime script.js into zkDAP. We had front end and we had created a scripts folder. And now if we go to the folder of our choice, we'll find that particular file. You can also choose to change the name of the particular file when you're doing this operation. Let me show you how exactly you can do that. Let's say we are picking up this style.css and let's drop it in the CSS folder. And let's call it zkcss or zk.css. Now, if we do an ls, you'll see that the name of that particular file would also be changed. Okay, we have now moved a bunch of files, but not every time we would want to move it, but we would also want to create copies of files. So let's just quickly understand how we can copy files. It's a very simple command. We can just simply use cp to copy a file from one place to another. We can also copy directories and copy them recursively from one place to another. So let's quickly do that. So where exactly are we at? We are in the snake game directory. So let's do one thing. Let's try to move the index.html file to our front end folder. So we say copy index.html to my front end folder. So if I now do ls on front end, it has my index.html file. Now let's say I want to copy the complete front end folder. Or let's say, let's go to the zkDAP folder because it has more number of files. Now let's move a bunch of things around from circuits to contracts. And let me just do a quick check on circuits. So I have this thing called a test directory, and I also want these tests to be available in the contracts directory. So I'm going to say cp test right? From my circuits folder, pick up the test file and put it in the contracts file. Now it says that it's a directory, it cannot be copied. We obviously have an option that lets us do that. We basically say that recursively copy all of these things and it'll be done. So now if I look at my contracts, it has the test directory present. And if I look at my circuits, it also has the test. So we've basically just created a copy. That's how simple it is. Now let's understand that how do we get rid of unnecessary things that we have moved around, right? How to delete directories, how to delete files. So deleting a file is pretty simple. Let's say that I want to remove this README file. So I say rm, just delete it. So when you do an ls again, it's no longer present. But what if you want to wipe out a complete folder from a particular subdirectory? Let's say that I do not want, let me see, what does this have? Let's say I don't want this front end folder anymore. So I'll say rm minus r, the front end folder. And it just wipes off the entire folder. If you look at the directory now, there is nothing that is present in us. And that's how simple it is to interact with files, folders, and anything to do with your directory structures. What we're going to look at next is how to interact with files in a greater detail, and also at the same time, how you can do a bunch of file operations right from your bash commands. Talking about files and what are the different things that we can do with files. So let's go back to our long form output that we had received from ls-l. If you look at the first column, it talks about permissions. So there are three different kinds of permissions. There's a read, write, and execute permission. And if you see, there are three sets of these. The first set is for the user, which is currently me. Then there's a group, which currently for me is defined as staff. And then there's an others permission. If you want to create a separate, the default permission, or for others, you can use the third part. So there are two ways in which you can decide what permissions that you want for a particular file or a folder. You can go either the symbolic way, which will be using R, W, and X symbol, or we can go down the numeric way. So let's first look at what the command is, and then we'll look at different ways in which we can change the permissions as per our requirement. So the command is called chmod. Now, the first thing that we need to specify for this command is who is it that we want to change the permission for. So chmod command takes in two things. One is who are you setting the permissions for? Is it the user, is it the group, or is it the others? The next thing it needs to understand is, what are you doing? Are you adding a few permissions, or are you removing a few permissions? I mean, are you setting few or revoking a few permissions? And then what you need to tell is, what kind of permissions are you adding? Is it read or just write, or is it read, write, and execute? And then you have to specify the folder or file you want to do it for. If it's a folder, there's obviously a minus R option that you'll have to add. If it's a file, you can just go ahead and do that. So let's look at our shell script, which currently doesn't have execute permission, right? So what we're going to do is we're going to say chmod u plus x for my new script.sh. And again, when I do ls-l, you'll see that the execute permission has been added. Now I say that I want to also give write and execute permission for my group as well. So all I need to do is I need to say that the group can write and execute this. And it's as simple as that. Now I feel that there's a file called file1.txt, which has write permission and execute permission, right? I don't want this file to have execute permission because it's not relevant. So what I'm going to do is I'm going to say chmod u minus x and just revoke this permission for this particular file. And the file permission is instantly reflected. Now, I had mentioned that there are two ways in which you can use this command. One is through symbols, which we've seen. Another thing that we have with us is basically using numbers to do that. Now, if you look at how this numeric method works, we have each digit, which represents the permission. So 4 is for read, 2 is for write, and 1 is for execute. And how this works is that, let's say I want to basically give only read permission to my user, only read permission to my group, and only say I want to give write permission to only the group for my folder 1, 2, 3, 4. So what I'm going to do is I'm going to say chmod. I'm going to say 4, and I don't want to make any changes to my user or the others. So I'm going to say no changes there. That can stay as is. So read and write can stay as is. That will be 6. What I'm making a change here is that I want to add read and write here as well. So 6. And here, since it's read, it can only stay 4. And I say 1, 2, 3, 4. And now when I look at it, you'll see the difference that a write permission has been added to that particular file, which is 1, 2, 3, 4. Now, what actually means is that when you are describing the access for a particular user group, a user, or the others, you basically add all of these together and that number represents. So if I want to, let's say, have all the permissions for this particular file, it'll be 7. So if I say, let's say chmod 777 to 1034, what you'll see is that it has all the permissions for all of the user groups. And that's how these permissions work. And these are very important when you're dealing with executables, when you're dealing with files of different kinds. And you can also basically automate this when you are working. We'll talk about how you can actually do away with doing all of these things within a terminal, but actually do it through a script. Now, let's say you want to display a certain message in your terminal. You can just say echo hello world. And we talked about the echo command of how we can display certain messages or certain environment variable right onto your terminal. So for that, we have a command called echo. So let's say I want to display a particular message. Let's go with the classic, which is hello world. I can just give the message and I can display it. We can also look at certain environment variables, which most commonly could be your path variable, and you can look at how your current path is looking like. And that's how simple echo is. Now that we've interacted with files a little bit, let's also understand what are the different things that we can do beyond just viewing the file or making some amendments to the file, like adding, adding a bunch of things to the file. Now we have a file called newfile.txt. Let's just quickly have a look. It has 1 to 50 in a different format. Now let's say that I want to look at only the top of the file. I can use the command called head, and I can pass the file name, and it'll give me the first 10 rows of that particular file. And what if I want to see only the last 10 rows of the file? I can just use the command called tail, and it'll give me the last 10 rows of the file. Now, what if I want to see a specific set of rows from my file? Let's say head, and I want to see the top 20. So we use -20. And we just pass the name of the file. And there we have the 20 files, and we can repeat the same thing with the tail command as well. Now, let's say I want to view only a certain section of my particular file, right? And not the entire file. So I have to use the head and the tail command together. So let's say I want to view my file from line number 25 till 29. Now, how do you combine two commands? So far, what we had seen was that we can use the AND operator and combine a bunch of commands. But here, what we are trying to do is whatever output we get by using the head command or the tail command, we want to do something on top of it so that our scope or the number of rows we get gets changed. So we use something called as a pipe operator. Now, what pipe operator lets us do is that if we have command number 1 and we have command number 2, so whatever output comes from command number 1 flows to command number 2. And that's what our pipe character helps us achieve. So having said that, what we're going to do is we're going to say tail. We're going to use an option called -n. We want to start from the 25th row of our new file. And then we want to say that just give me the next 5 rows after that. So this is exactly what we needed. And now you can tweak these ranges as per your choice to view the number of rows of your choice. Now, another thing when it comes to files is to basically check how the file is looking like or get a basic set of stacks about the file. So let's say I want to look at the line numbers, the word count, or probably a character count. So I can just use a command called WC on top of my file. And I can look at the number of lines, which is 50, the number of words, which is 68, and the number of characters. Now, a lot of the times you would want to use this file in conjunction with other things. Let's say you are trying to search for a particular occurrence of a word within your file. Now, in order to do that, we have a command called grep. Now, grep is a command that lets you find occurrences of certain words or phrases or a regex or any particular expression within a set of files or a directory or a project of your choice. A very simple example of this would be, let's say I'm just trying to see how many times one was used within this particular file. So I'm just going to do a grep and I'm going to get all the instances of this particular. Let's say if I want a stat of how this happened, I can just say that 3 times there was an occurrence that happened. I can also just ask it to give me the occurrence by using the -l option. Now let's look at in greater detail what are the different ways in which we can use the grep command. So grep is a command that generally is used for us to find patterns, regexes, certain phrases within a set of files or directories. So let's get to a little bit more options that are available within the grep command. Now understand how the basics of greps look like. Now, this was one way of understanding the number of occurrences of the word one in a particular file. We could have very well done this with the multitude of options that comes with the grep command. You can just say grep -c, which means that only print the count of the number of lines in which this particular occurrence happened, and you can give the name of the particular file. And that should be it. I think let me just retype the name, the phrase that I'm actually searching for. I missed that. And you see the output is again 3. Now let's say I actually want to see the lines where, or not the lines, but actually the occurrence of those particular places where this phrase was available. So I can change this option to -h. So it will give me all of the matched lines, right? Now, let's say that I have a particular file where one can be in different cases. So I can use the command, which is hi, and it'll be able to give me all of the matching sans the case. In order to illustrate it for you, let me just make a few changes to this particular file, and let me insert a few things here and there. And let's see that do we get all of these after introducing the, let's say I just look for one. So I'm only going to get these 3. If I'm also going to say that ignore the case and just give me everything, you will see that all of the new additions that we have done to the file also start coming up. Now let's say that I want to look for the occurrence of one, not only in this file, but across a given directory. And I want to retain my choices, that I want to see the file occurrences. I want to ignore the case, but at the same time, I also want to see it for the, I would say, current directory. So I just specify the directory, and it occurs in a lot of different places. So if you look at it, it gives you the details of the file where it is. It also gives you where it is occurring because we have used the -r operator with it as well. Now let's say I still want to do the operations on my given file, but I also want to see the line numbers. I also want to see the lines more properly. I just want a more verbose output. So I can just get the line numbers accordingly. I mean, these kind of things are more important when you're working with a lot of shell scripts, when you're working with bigger projects, and you just quickly want to check a few things. Another 2 very important options that are available for grep is -w and minus O. Now, minus W means that we want to match the whole word. We're not looking for places where one occurs in the middle of a word, but we only want to match the whole word one. Now, to instantiate what I'm saying here, just go back to edit this file again. And let me say, let me just add, random words with one. Now, if I do not use the minus W option, I am going to get the output as follows. Okay. And there's another option called minus O, which basically gives you only the matched parts. If you want to see it without this is what your output would look like. And that is how generally grep works. You can use grep with a lot of these options. You can use grep with pipe commands as well, which is how it's generally done. Okay, now that we know how grep works, let's just do a quick recap of all the things that we have seen today. It's been a lot of different commands, so you can just view the history of all the commands that you have ran. It's a good way for you to go back and refer to any of the commands that you might have missed. And it's a pretty simple operation. Now, if you look at it, there would be instances where you would have to move a lot of files from one place to another during the execution of a program, or would want to move runtime files from one place to another. And in those cases, you would ideally not want to do this task manually, but rather automate this through the form of a script, because Bash is just not a bunch of instructions that you give through the prompt, but it's also a language. So you can put it into a script together and have that script being executed. So what I've done is I've actually created a file, or rather a script. Let me just show you that script real quickly. So we're going to use cat command to view the script. Now, what we need to do is we need to basically tell, the first line represents that we're going to be using a bash script, and we've specified that in the beginning itself. Now, the first thing I want to do is I want to say hello world. In the beginning, I'm using echo. Then I'm creating a new directory called automated directory. And then I'm going into that directory and also creating a new file called new script file.txt. Now, in order for me to do, since I already have these files, let me just change this file a little bit for us to have a little bit more insight into what's happening. And let me just create, I'm just adding a new alias to it. Now, all we need to do is we say bash, we say new script, and just execute it. And it says hello world to me. Let us look at our directory. So we have an automated directory too. Let's ls into that directory. We also have a new script file2.txt. So we can just do a quick ls minus LT on this and check that it was recently created and it's an empty file. So that was all about the bash commands that we wanted to discuss today. Obviously, there are a lot of different commands that are available, and you can use these commands in conjunction with the individual ones that we have discussed today. And with time, you just get better at it. Now let's move to something which is very popular among developers is Node.js. We're going to install Node.js in our systems. Now, I know a lot of you would be using Windows, some of you would be using Unix, some of you would be using Mac. So I'll talk about how you can set it up in all of the different systems. So let's get started. All right, so now that we want to install Node.js, let's just quickly understand what exactly is Node.js. So it's an open source server environment, and it uses JavaScript as the server. It also supports asynchronous programming, which means that you do not have to wait for the response to come back, and you can keep sending more requests. And while it's a topic for another time, let's get to installation part. So the first and the most easiest way if you're a Mac user is to use Homebrew to do the installation. In case you do not have Homebrew installed, you can go to the official website and follow these steps here to install Homebrew. Once you have installed Homebrew, the installation for Node.js is pretty simple. Let me go to my terminal. All you need to do is say brew install node. Since in my system it's already installed, it will only look for any updates, if any, and we'll wait for it to complete. All right, now that the installation is complete, in order to verify if the version was correctly installed or not, all we need to do is node -v. And if you're able to see the number of the version, congratulations, you have set up node. But what if you are using a Unix machine and Homebrew is not supported? So there is also another way of doing it. In order to do that, let me show you a bunch of different steps. So what we can do is we can use the NVM installer, which is the Node Version Manager installer, to first basically set up the installer and then use a bunch of operations to set up our node version, and then we can pull the node version correctly. So what I'm going to do is use curl. You can use curl or wget, whatever works in your terminal, and set up the installer. I already did that for you. So let me just show you the kind of output you can expect. So since our NVM is already installed, you wouldn't see anything being downloaded. Now, once the NVM is installed, we would have to make some changes to our bash file. In this case, it'll be a ZSHRC file because I'm using a ZSH shell. All we need to do is we need to navigate to our file and add this particular configuration, which makes sure that the directory or the path directory is pointing correctly. Then we need to source it back again so the changes are effective. And then we need to make sure that the NVM is installed so we can quickly check that the version is there. And then all we need to do is we need to say NVM install node, and your node version will be installed. Now, since it's already present in our case, it'll just override the existing installation, and voila, you will be done with the installation. We can quickly verify the version, which will be 21.4.0. So it just got updated. Now, coming to people who are using Windows machine, or you're not able to do something with the help of your terminal, you can actually use the distribution of the Node.js website, and you can download the Node.js package, download it, run it, and you would be good with the installation. And that's how simple it is to install Node.js in your system. Once you download, you will see a package file. You can just run it, execute it, and you would have Node.js running in your system. All right, now that you have made towards the end of this video, we have some advanced commands that come in really handy when you are working with files. And when it comes to text processing in Linux, we have a lot of different things that we can do. So we talked about grep. There are two more advanced commands called sed and awk, and we'll be taking this time to talk about these so that it's easier for you to work with these files and also do a bunch of advanced operations apart from just matching and searching on your files. Now, while all of these three give a lot of functionality in terms of text processing, and they are also very similar, each of them come with their own advantages and also certain additional functionalities. And there will be a heavy overlap in what each of them can help you achieve. When we looked at grep, it's really, really good for achieving pattern matching and just finding certain matches and printing it out. When it comes to sed, it can do all of those things, but what makes it stand out is the substitution feature that you can do. And you can do that in place for a given set of file. And awk, being the most powerful tool out of all of these, is a scripting language in itself. And it comes with a multitude of different features, which lets you do arithmetic operation, comparisons, calculations, custom fetching of files, and a bunch of different things. So let's just understand a bunch of things with grep. Then we'll try to see how we can go from simple matching operations to much more advanced operations. So what I've done is I've created a file called log.txt. And these are generally how our logs look like. And what we're trying to do is figure out how we can look through this file and understand a bunch of different things. So let's say I am looking at getting all of the error messages that are there in my file. So what I'm going to do is I'm going to grep, say error, log.txt. We're very familiar with that. So what it is going to do is print all of the error fields for me. Let's say I want to only look at everything else apart from info, because generally when we are looking at logs, we want to omit any information messages. So we can use the -v operator to basically get all of the details apart from info, which is essentially our error message. Now, when it comes to these log files, a lot of times we need the preceding lines as well as the succeeding lines that are present after the error messages. So we have a bunch of different options to do that. We have -a that lets you look at all of the lines after the occurrence of that. So we're going to look at that. So after the error, we can see the 5 different lines. If you want to see the lines before, we have -b as an option available. And if, let's say, you want both the preceding and the succeeding lines, we have -c that lets you view everything before and after it. And that's like an extended functionality that grep provides you. Now let's look at cases where we would want to make changes in our file, change the occurrence of a certain pattern, which is something that we cannot achieve with grep. So we have a command called sed that lets us do that. So let's just quickly understand what sed is. So sed is nothing but a similar text, I would say, processing operation that comes in your Unix. So similar to all the other commands, we have options. What is different here is that what we want to do on each line of that particular file, we need to define a small script. And when I say that substitute command is the most popular one, this is how the pattern looks like. So we say that S is the word that defines that we are looking to replace. We specify what pattern are we looking to identify, and we tell what do we want to replace it with. So first, before we get started with doing a bunch of operations, let's first understand, can we replicate the functionality of grep with sed command or not? We obviously can do that. So let's just quickly look at that. Okay. I'm going to find the command. So what I'm going to do is sed. This is the phrase I'm looking for. And then I am specifying the word p because I'm saying that print out whatever you find. The reason why I've specified -n is because sed will print all of the lines that it finds in its output stream, and we don't want to do that. And hence we've specified the -n. And voila, we have the same output. All right, now that we know that it's able to replicate the functionalities of grep, let's now try to replace the occurrence of error with something called critical. And as we talked about, all we need to do is specify the pattern which we're looking for with the replacement phrase. And that's how simple it is for you to do that. So if you see, the occurrences of error is replaced with critical. Now let's say that we don't want to do this for the entire file, right? Maybe only for specific instances we feel that the error is critical. So we can choose to apply it only on certain number of lines. But before we do that, a lot of you would be thinking that, I don't want to make changes to my file. I want to keep a backup in case something goes wrong. So we do have the functionality to do that. So we need the -i option. What it is going to do for us is that it's going to create a log.txt backup file for us where the original file is going to be persisted and the new file is not going to be impacted. So if you look at it, there's a backup file that has been created. Now I was talking about how you can do it only for a specific set of files. A specific set of lines. So all you need to do is specify the line numbers for which you want to do that. So we see that, okay, let's just change the pattern because we have already edited our file. Maybe let's say that critical needs to be replaced with very critical, right? And I only want to do it for line number 3. And since line number 3 doesn't have the occurrence of that, so let's just increase the range. Let's say I want to look in line number 3 to 5. And in this case, Now, again, we missed that. So we can probably change the range to 3 to 7. And we see that the replacement happens. You can also basically move this range right back into your pattern and just print it out before you actually do the operation. You can just test it out by moving the range over which you want to do this inside your regex pattern itself. And that's how simple it is to do substitution in place and at the same time retain your original file without having to write scripts to do that. And now we come to a rather the most powerful tool when it comes to text processing in Unix. It's called awk. Awk is in itself a scripting language very similar to how Perl functions. And awk also has similar structure as SED, but the number of features that it comes with is it's a lot. We again have a lot of options available to us. We have a script that we specify. The way we specify scripts here is actually different. And then we specify the file over we want to do it. How are patterns defined here is that what pattern are we looking at? Let's say we're looking at error. We need to specify what action we want to do. Do we want to print it? Do we want to replace it? Or do we want to do something else with it? So first, what we're going to do is try to replicate the functionality of the grep command itself. So let's go ahead with it. Since error doesn't exist anymore, I'm going to change this to critical because we have edited our file. So I'm so sorry. Yeah. So we're going to change this to critical. And we have all the occurrences of the critical word with us. Now, let's say that we now want to replicate the functionality of SED, right? So what we're looking at is potentially a substitution. So let's look at how we can achieve that. Now, instead of substituting error with critical, let me go ahead and substitute critical with error back again. And if you look at it, we are able to do all of the things that we were able to do with SED right with awk. Now, what we are saying is that gsub, the pattern, find this pattern, replace it with this, and then print it. So we are not making any changes on the file. We're just printing it out. Now, this is just the basic functionality of what we can achieve. Let's say we are looking to add some header and footer text to a particular file. So we can do that with awk as well. As I said, it's in itself a good scripting language and it can help you achieve a lot of things. So we are just saying that this is a log summary and this is end of log summary. And that's how simple it is to add text. So what helps us do this is the begin and end phrase, similar to how you have in any other scripting languages or similar to how you have in SQL-based languages. We use the word begin and end to specify what is the text that we are looking to add. Now, another thing that awk is really useful for is when you're dealing with columnar data, CSVs, where you have different structures of data. In those cases, you can actually cherry pick the data that you want to pick and do a bunch of operations on. So here, what we are doing is we are actually picking the first and the second column of the data, which is this. So if I just very quickly show you how my file looks like, we have basically taken the timestamp and the category column. So let's say if you want to pull a particular category of information from this data, you can just specify $2 as your column. You can check if it's info or it's critical, and then go ahead with doing whatever operation you want to do. And that brings me to the next thing. Let's say that by default, white space is the delimiter that it goes ahead with. But in case you want to specify a specific delimiter, you can use the -F option, specify the delimiter of your choice, and then pull up the file of your choice. And now comes the interesting part where I basically wanted to do a bunch of arithmetic operations on top of my file. Let's say I'm trying to understand from my log file how many times a particular error has occurred, and I'm trying to count the occurrences. Generally, I mean, one way is that we do a grep, do a word count, and then do a bunch of other things on top of it. Here, it's very simple. We've specified in a script that we want to take the second column and count the occurrences of this particular string called error in my file called log.txt. So let's go ahead and execute it and see if it's able to perform as expected. Okay, let's just quickly, since we have changed the occurrence of error to critical, let us change this command a little bit and say that we are looking for only info. And voila, we have 6 occurrences of info. Another interesting thing that you can do here is that let's say you are trying to pull logs only after a certain timestamp. Let's say, let's pick up one timestamp of our choice. So we want to say that only and only if my first column, which is the timestamp, is greater than this. That means I'm trying to look for all the records older than this timestamp. I only want those records. And that's exactly what we get. And this was a way in which you can make your text processing and text manipulation in Unix really, really fast. And these will come in really handy when you're working with a lot of log files and when you're working on bigger projects which have a build trace or a stack trace that you are trying to figure out. And with that, we come towards the end of this video. I hope you learned a lot about bash commands. You were able to set up Node.js in your systems.